So yeah, good afternoon, everybody. My name is Greg Swiss. I'm an analyst at Cyclone. So a lot of times when we come into buildings, we get a bunch of first questions about how their building operates, and we run into some funky situations. So hopefully I'm going to try to answer some of those funky situations and with these myths. So first myth I'm covering is how do buildings actually use energy? Is it lighting? Is it computers? Is it heating? That's really the most important part in our buildings in Chicago. We use a lot of computers these days. We have a lot more lighting. Buildings are occupied longer. What's really the most important part? So actually, if you look at an office building in Chicago, heating is going to be the biggest part. And these percentages might vary a little bit, but surprisingly, they're pretty consistent throughout the buildings. Fans are important. Interior lighting is important. Hot water, hand washing isn't that big of a deal in the office. If you look at an apartment or condo, some things are similar, like heating's now even bigger, right? Hot water changed from being the smallest to now it's the second largest, right? Lots of showers, lots of dishwashing, lots of laundry, that adds up. Next myth is what's more important to a building's energy use when it's occupied or unoccupied? And I would kind of argue that when it's unoccupied is actually more important to a building's energy use and its performance. We find a lot more opportunity for savings when it's unoccupied. So think about your typical office building. It's occupied 14 hours a day. It's open Saturday, Sunday even. It's only occupied less than 50% of the time during that scenario. So unoccupied time is actually a huge component of its energy use. That's really surprising. Residential a little bit different, but offices definitely unoccupied is important. So this is a graph of electricity use for two identical buildings throughout 24 hours. And we see this all the time. Building 1, for some reason, is using twice as much energy at night as building 2, right? So that's like the lowest hanging fruit, nobody's there, biggest savings. The next myth, which is probably the most controversial, is do temperature setbacks actually work? Do they save energy or do they waste more energy? I'm going to say unequivocally they save energy. I've never seen a high-performing building that didn't use temperature setbacks. But I put a small asterisk there, which is basically if your building has a heat pump system and electric resistance heat is backup, sometimes that backup heat will turn on when the system's trying to warm up. So that's a small thing you gotta watch out for. But basically, do setbacks, don't let anybody argue with you. They save energy, and a lot of it. So next myth is who uses less energy? New high-performance buildings or kind of older, a little bit outdated buildings. With the offices, what we've seen is anecdotally for a long time, old buildings tend to perform better than some new buildings, right? And now we actually have some really good data on that. So New York started benchmarking their buildings, which means tracking all its energy use. And you can kind of see with the different decades of buildings, there's really no trend between office buildings and multifamily buildings and the age of the buildings and its energy use. Chicago, we're benchmarking here too. Kind of same results. It's a little unfair to compare a building in 1880 to a building built last year, but even if you look past 30, 20 years, there's more diversity in the buildings within that decade than from decade to decade. And really, I think the issue is there. A building can perform better. It doesn't necessarily mean it is performing better. So a lot of times it's a controls issue. We come into an older building that might not be as performing as well, and we're able to tune and adjust it and get it working a lot better than a lot of new buildings that we actually see. So it's just because it's new doesn't mean it's better. It's like the 92 Dream Team, right? Everybody wants to have a building that performs like them, and we see a lot of buildings that do perform like them. A lot of classic buildings that just really kill it. The last myth I have is, when you're installing new equipment, does it take more energy to produce that equipment, to ship it to your site, to install it, than it actually is going to save? And so the classic example here is, LED light bulbs, right? There's a lot of metal in them, a lot of electronics. Do you actually save more energy than what's required to manufacture them. It's like the whole idea of embodied energy. So if we look at a couple of examples here, look at the energy use between materials, manufacturing, transportation, compared to its direct use. We'll see kind of some interesting trends. So look at airplane, refrigerator first. You can see that the airplane, by and large, uses more energy directly, right? It doesn't matter if the airplane was suddenly made out of platinum or titanium. That's so insignificant to how much it uses directly. So that's really the story there. With a refrigerator, a little bit more materials, but it's more about use. Parking garage is the opposite, right? All the concrete, all the metal that goes into them trumps the little bit of lighting energy use that you have. Commercial office building, more towards use. Quite a bit of materials go into it, but the energy use throughout its lifetime is way more important. So there's the energy myths. Embodied energy is something I'm really interested in. So if you want to talk about the paper bag versus plastic bag, you can come see me afterwards. I'll give you an earful. Thanks.